Achieving a properly brazed joint involves a number of important key activities that must be followed each time brazing is undertaken in the field. The first key to a successfully brazed joint is the proper preparation of the joint. The second key is proper brazing technique. The third key is regular practice on a number of joints and various components to ensure that successful brazing will be possible each and every time it is called for on the job. All joints should have good fit and clearance before they are brazed. Copper and steel tubing of a particular size will generally slip snugly into the next largest size of tubing. For example, 1/4 inch tubing will slip into 5/16 inch tubing to create a self-supporting joint. The smaller tubing should be overlapped by at least one diameter of the larger tubing. For example, the 1/4 inch tubing should be inserted at least 5/16 of an inch into the 5/16 inch tubing. Two pieces of copper tubing of the same size can be joined together by expanding the diameter of one of the tubing ends with a swedging tool. The expanded or swedged end should overlap the smaller tubing by 1 diameter. Always support the swedging tool with your hand. Don't expect the tubing to absorb the force of the hammer blows. The tubing will bend or collapse. Never swedge steel tubing. Steel is much harder than copper and will split if swedging is attempted. When brazing copper to steel, swedge the copper tubing if there is a misfit. Tubing pieces with large differences in size can be joined by making a pinch joint. The most common occurrence of this is joining capillary tubing to system tubing. To ensure that the capillary tube will remain unrestricted when brazed in place, insert the capillary tube at least 1 inch into the larger tubing. Pinch the larger tubing around the capillary tube with a pair of pliers. Make sure the end of the larger tube is pinched as tightly as possible. Be careful not to pinch the capillary tube itself. A properly fitted joint will be self-supporting without being brazed. A joint should be tight enough to hold itself together. The tubing should not rock or flex when together. When assembling a number of joints, fit them all together first and then braze them all at one time. Begin with the joint furthest away. This procedure will save time and avoid the possibility of joint separating and dripping solder where it's not wanted. It is always a good practice to clean all areas that will be brazed. All metal surfaces should be thoroughly cleaned with refrigeration sanding cloth. Tubing that is going to be cut with a tubing cutter should be sanded before the cut is made. To prevent the introduction of contamination inside open tubing while sanding, place a swedging tool in the end of the tubing. Use only sanding cloth that is specified for refrigeration systems. This material does not contain lubricants and chemicals that could contaminate the sealed system. Such materials as emery cloth, acid, or steel wool should not be used to clean tubing. The proper application and the use of the right type of solder will ensure a strong, leak-free joint. Silver alloy solder melts very quickly. To conserve the amount of solder used on each joint, bend over a short L at the end of the solder. 1/2 inch of solder is sufficient to braze most joints. When the joint is hot enough, hold the short end of the L to the edge of the joint. When the short L has been drawn into the joint, take the solder away. 2 types of silver alloy solder are recommended depending on the type of joint and metals involved. Copper to copper joints can be brazed with 15% silver alloy solder. This material is commonly referred to as Silphos. This solder does not require flux, thus eliminating the need to remove residual flux from joints after they're brazed. Silphos is very rigid and provides a strong and secure joint. The lower amount of silver in this alloy generally means the solder will be less expensive than 45% solder. Silphos has a high melting point which could lead to overheating the joint when brazing. Silphos must not be used on copper to steel joints. The solder contains phosphorus, which could react with the steel and cause contamination of the sealed system. Copper to steel joints must be brazed with 45% silver alloy solder. Copper to copper joints may also be brazed with this solder. Solder with a silver content of 45% has a lower melting point and might be considered when brazing small diameter tubing. This solder always requires the use of flux when brazing, and the joint must be cleaned to remove any flux residue. This solder has 3 times the silver content of Silphos and is generally more expensive. The proper use of flux will ensure a strong, leak-free joint. Copper to steel joints must be brazed with 45% silver alloy solder and flux. Flux acts as a wetting agent which allows the solder to flow into the joint through capillary action. Flux also prevents steel tubing from oxidizing during brazing and removes any remaining surface residue. Flux also acts as a temperature indicator. As flux is heated by the flame of the torch, it will first start to bubble, then dry and turn white. Finally, it will turn clear and water-like. This is an indication that the joint is hot enough for the solder to flow properly. It is necessary to remove any flux residue from a brazed joint. The residue is caustic and will corrode the joint over time and cause the joint to leak long after the repairs are complete. Applying the right amount of heat will help to ensure a properly brazed joint. If you are brazing near any aluminum weld joints, near a brazed-on access valve, or tubing that goes into the cabinet liner, a generous amount of heat trap paste should be applied to protect parts that could be damaged by the heat from the flame. Applying heat to a joint will depend on the type of torch that is used. The flames on a double-tip torch should be adjusted to a slender light blue cone by turning the pressure regulator on the fuel tank. The hottest part of the flame is the inner bright blue portion. These 2 bright blue flames should graze each side of the tubing. Both nozzles of the torch are easily adjustable to accommodate any size tubing. The hottest part of a single-tip torch flame is the bright blue portion right near the nozzle opening. The pressure regulator should be turned full on. Brazing temperature must be controlled by varying the distance between the torch tip and the area being brazed. Any metal acts as a heat sink during brazing. This means that the metal tubing will naturally carry heat away from the brazing area. To compensate for this, there are 3 common rules. Always hold the torch on the larger of the 2 pieces of metal being brazed together. This will apply more heat on the larger of the heat sinks and distribute the heat more evenly. Hold the flame on the copper tubing on a copper to steel joint. Copper is a better heat sink than steel and will require more heat to reach the proper temperature for the solder to flow. When the tubing is hot enough for the solder to flow, move the flame of the torch down the length of the overlap of the joint to pull the solder into the joint. Once the solder is flowed into the joint, immediately remove the torch. If the tubing is hot enough to glow bright red, the joint has been overheated. When this occurs, the inside of the tubing will be scorched, leaving a scale. This scale may eventually break loose from the tubing and contaminate the sealed system. If a copper-to-copper joint has been brazed properly, a small bead of solder called a fillet will form around the joint. A copper-to-steel joint will not have a noticeable fillet. Cleaning and inspecting each joint for possible leaks will ensure a trouble-free repair. A small inspection mirror should be used to examine each newly brazed joint. This will allow a thorough view around the entire joint. The solder should completely surround the joint. Potential leaks will appear as small pits or black holes in the solder. If these appear, the joint should be thoroughly cleaned. If flux was used, first clean the joint with a pair of pliers to remove flux residue. All joints should be cleaned with a wire brush and refrigeration sanding cloth. The joint should then be rebrazed and inspected again. Good brazing technique develops over time with lots of practice. You should take the opportunity to practice brazing often. A specially designed brazing exercise kit has been created to provide practice in brazing a number of different types of joints and working with a variety of components. Practice activities include brazing a copper-to-copper slip joint, brazing a copper-to-steel slip joint, creating and brazing a pinch joint, creating and brazing a swedge joint, and brazing a saddle access valve onto a sealed system. Brazing reservoirs and accumulators into sealed systems presents special problems. They are very efficient heat sinks. Practice brazing these components with both a double-tip torch and a single-tip torch. The job aid provides a list of specialized equipment by manufacturer with part numbers and sources that will help you produce properly brazed joints. This